So this, you have a prototype bridge model. So it is having around 7 meter length. So it is a simply supported beam. So you have two types of loads here. So one is a point load, which is 7 kilonewton. The other one is a UDL, which is 4 kilonewton meter for 3 meters. So from here to here. So the carriage, whatever it is, that is 4 kilonewton meter. So the question is, they are asking two questions. Number one, they have to identify what is the deflection and slope. What is the slope and deflection at 5 meter? That is my first question. And the second one is, you have to identify maximum deflection. So this is maximum deflection. And you have to check it out whether it is less than 7 mm. If it is less than 7 mm, then you can say that this setup is okay. If it is not, you have to give some suggestion. So to make this setup, you have to give some suggestion. So this is the overall question. So this is the main question which is having the diagram, application diagram, which has to be converted to a free body diagram. So how to convert this as a free body diagram? So just let me do it here. Your box. This box is simply supported, which means this side you have a simply supported bar. This also, this side is also, it is simply supported. It is fixed. And now it has a point load. So you have a point load here. So let me identify what is the point load. So this is my point load here. Okay. This is my point load. So what is the value of the point load? 7 kilonewton. So this is 7 kilonewton. After that, you have a UDL. So this is for 2 meters. After that, for 3 meters, you have a UDL. So UDL is like this. So from here, you have a UDL like this up to 3 meters. Okay, let me consider up to this is 3 meter. So this is 3 meter. The remaining 2 meter is here. My UDL is 4 kilonewton meter. So what is the value of the UDL? UDL is 4 kilonewton per meter. Okay. So let me name this. So I will call this as A. I will call this as B. This point where your UDL ends, that is C. And this one is D. The first step is I have to identify what is the reactions. How to identify the reactions? So you have two reactions here. One is RA. Other one is RD. Let us identify what is the reactions RA and RD. Before that, let us fix our unit. So the problem here, everything is in meter and kilonewton. So my unit is kilonewton and meter. So this is my unit. So based on this unit, let us solve the problem. Sorry. Right. So just look at this. They are given one value, which is EI. EI is already in kilonewton meter, so no need to worry. So directly we can write. So your EI is 14,000 kilonewton meter square. This is already in kilonewton meter square, no need to worry. Okay, let us proceed with this. As per EMEC, so engineering mechanics, same procedure. Upward force is equal to downward force. What are the forces which is going upward? RA and RD. So RA plus RD is equal to downward force. Downward force, you have a point load and a UDL. So point load is 7 plus UDL is 4. 4 is my kilonewton per meter. So how many meters? 3 meters. So 4 into 3. So this is my UDL. So what you will get? You will get RA plus RD is equal to, so 12 plus 7. So totally 19. This is equation number 1. Now let me take moment. Let me take moment at A and equate it to 0. So when I take moment at A, this force doesn't have any distance, 0. This force RD. RD is having a distance of how many meters? So you are having 7 meters. So force into perpendicular distance. So RD into 7. RD into 7. So this is rotating in anti-clockwise. So I'll consider that as positive. Other things are rotating in clockwise. So negatives. So minus. Let me go for the point load. This point load is having a distance of 2 meter. So force into perpendicular distance. 7 into 2. So minus 7 into 2 minus UDL. So W into L by 2 plus offset distance. So 3 into 4 or 4 into 3 into 3 by 2. So force into perpendicular distance plus offset distance. What is my offset distance? So it is offset distance for 2 meter. So 2. So this is equal to 0. So now can you tell me what is the value of RD? So let me write it again. So RD into 7 minus 14 minus 12 into, so this is 1.5. 1.5 plus 2, 3.5. So this is equal to 0. So what is your RD? So RD is 8. Substitute this in equation number 1. You will get RA. So RA is 11 kilonewton. So this are the two values. I identify what is the values. Okay. So I have identified what is my RA and RD. So my RA is 11 kilonewton and RD is 8 kilonewton. Okay. So these are the values. Now, so you know what is Macaulay's method. So Macaulay's method, you have to take a section after completing your UDL, after completing your loads. So you have two loads. I have to take a section here. I'm going to take it here. Okay. But there is another condition. This is applicable for UDL. So in Macaulay's method, if I consider a UDL, so UDL starting point is here, but ending point should be up to the end. So that is another rule in Macaulay's method. So whenever you have a UDL, starting it is up to C, right? So starting is B and ending is up to C, right? But it has to be up to D. So I have to change this UDL so that your UDL is up to D. So what to do? How can I change this? I can add this UDL. So from C to D. And I will subtract the UDL downwards. Are you getting it? I am adding a UDL up to C to D and subtracting the UDLs up to C to D. So I have two UDLs here. So this makes it same. There is no change in the beam. But it is also satisfied according to Macaulay's rules. Now, if I figure it out, I have one point load, which is 7 kilonewton. I have two UDLs. First one is 4 kilonewton meter, Newton per meter for 3 plus 2, 7 meters for, 3 plus 2, 5 meters. The second one is, I have another 4 kilonewton per meter downward direction. Okay, so it is below for 2 meters. So you have three loads. So one point load and two UDLs. Okay. So one will be positive value, other will be negative based on clockwise or anti-clockwise direction. Okay. So this is the values. So now I will consider this as XX. So now what I can do, I can able to consider this. So from here to here, I'll call it as X. So in that case, what is this distance? What will be this distance? 2 is subtracted. So it is X minus 2. Similarly, what is this distance? What is this distance? It is x minus 3 plus 2, 5. So x minus 5. So how to take my bending moment? I'm going to take from left to right. Left to right. When I take left to right, clockwise rotation, I have to consider as positive. Rotation in clockwise is positive. Let me consider. So moment at x. Let me equate it. So I am going to consider up to this entire thing I have to consider. So first let me start with 11. So 11 into x. Rotation, it is rotating in clockwise. So 11x. Next, 7. 7 into x minus 2, force into perpendicular distance. How it is rotated? Anti-clockwise direction. So minus 7 into x minus 2. Next, 4. So it also has 4. So 4 into x minus 2, right? So you know that it is a UDL. When you have a UDL, it is force W into L into L by 2, right? Same concept here. So instead of L, you have x minus 2. That's it. So minus 4 into x minus 2. This is load, force, into x minus 2 by 2. So what is this? It is nothing but W into L into L by 2. That concept. So L is nothing but x by 2, x minus 2. Okay. So W is 4. So 4 into x minus 2 into x minus 2 by 2. Okay. So this is the force which is actually that is also rotating in anti-clockwise. So that is negative. Okay. So these are the two things. Next what you have? Another UDL. So I have taken UDL from B to X. That is over. So this part is over. This part is over. Another one UDL is here, which is x minus y distance. How it is rotating? It is rotating in clockwise, as like 11. It is also rotating in clockwise. So it is positive. So plus, same, 4 into x minus 5 into x minus 5 by 2. Are you getting it?
Yes, sir.
Yes. Right? Okay. So now I will rewrite this. We know that your moment at any point x is ei d square by dx square. So let me relate this. So what will get? You will get ei d square y by dx square is equal to 11x minus 7x minus 2 minus, so this, it becomes 2x minus 2 the whole square. Okay, so 4 divided by 2, and this is x minus 2 the whole square. So plus this again. So when you divide it, so 2x minus 5 the whole square. So this is my value. So now we have to put that Macaulay's line. So where to put Macaulay's line? Wherever you have change in distances. So first one, so x, and this is x minus 2. So which means I have to put line here. Next, this is also x minus 2. So this 2 is single. So this is x minus 5. There is a change here. So I have to put a line here. Okay, there are two Macaulay's line here. Any doubt in this?
No, sir.
Any doubt?
No, sir.
Yeah. So now what you are going to do is let us integrate this so that we can identify what is the values of slope and deflection. So let me integrate it. So integrating once, so what we'll get? EI, we will get EI dy by dx is equal to 11. So x integrating will get x square by 2 plus C1, so one constant, minus, so this one, so as I told you before, this x minus 2 is a whole term. You have to integrate as a whole. So you can also consider this as capital X integrated, and you can substitute later. Similar to that. So here it will get 7. X minus 2 integrating will get x minus 2 the whole square divided by 2. minus 2 x minus 2 whole square. So integrating, what will get? We'll get x minus 2 the whole cube divided by 3 plus 2 again this one x minus 5 the whole cube divided by 3 x cube by 3. Okay, so I'll get my Macaulay's line. So this is my Macaulay's line. Same, there is no change. So this is first one. So indicating. So let me consider this as equation 1. Okay, this is my equation 1. Next, let me go to next integration. So let me go to integrate it again. So ei dy so dy by dx integrating again, you will get y. So is equal to, so 11 by 2 constant, x cube integrating. So sorry, x square integrating, you'll get x cube by 3 plus c1x plus c2 minus 7 by 2 is a constant term. X minus 2 the whole square integrating. What will get? You'll get x minus 2 the whole cube divided by 3 minus 2 by 3 is a constant. X minus 2 the whole cube integrating. What will get? You'll get x minus 2 the whole power 4 divided by 4 plus 2 by 3 again it's a constant. Integrating this x minus 5 the whole power 4 divided by 4. So now I will call this as equation 2. So I got two equations now, but anyway, I'm not going to use the first one. So it is not used till now. So I want to cancel this C1 and C2. So these are the things which has to be done. So how to do that? I can use boundary condition. So let me apply some boundary conditions. What is my boundary condition for this particular setup? So when I consider here, it is an unsymmetrical section. So I can't able to have, to worry a lot. So you know that these two sides are fixed, which means these two sides, A location and D location, doesn't have any deflection. Your deflection is 0. So that is my boundary condition, which means I can say that when x is equal to 0. So because A location is when x is 0. So when x is 0, you don't have y. So your y is 0. Second condition, when x is overall length. What is my overall length? So 5 and 2. So 7. So 7. When x is 7, again, your y is 0. These are my condition. So let me apply the first one. So first boundary condition. When x is 0, y is 0. So when I apply this, I have to consider the equation accordingly. So x is 0. So we have to consider only the positive term in your Macaulay's. So substituting x is 0. So I can consider the first equation, this part. When you substitute x is equal to 0 here, you are getting a negative term. Okay, don't consider, so minus 2 power 4 positive. Don't think like that. So only the inside term. Okay, so you are getting a negative term here. So you should not consider this. Similarly, this is also a negative term. You should not consider this. So my equation here is EIY is equal to 11 by 6, right? So 11 by 6 x cube plus C1x plus C2 plus C1x plus C2. This is my equation. In this equation, let us substitute x is equal to 0 and y is equal to 0. When I substitute, what you are getting? So 0 is equal to 0 plus 0 plus C2. Which means I can say that C2 is 0. This is my first thing. So this is 0. Okay, now let me apply the second equation. When x is equal to 7, y is equal to 0. So when applying 7, so positive, we should consider this one. This is also positive. So because 7 minus 2 positive, consider this also. This is also positive. So which means I have to consider the entire equation. Okay. So the entire equation has to be considered. So let me copy this entire equation. Put it here. So without this lines. So lines I don't want. This is my equation. So here in this equation, your C2 is 0. So which is 0. So other ones, let us apply it accordingly. So 0 is equal to 11 by 6. X is 7, right? So 7 cube plus C1 into 7 minus 7 by 6. So 7 minus 2. So 5. So 5 cube minus. So this if I cancel it. So you'll get 1 by 6. 1 by 6. Again. So 7 minus 2 is 5. So 5 power 4 plus. Again this you can cancel. So it is again 1 by 6. 7 minus 5. It is 2 power 4. So just substitute this. And can you tell me what is the value of C1? So just bring every term on the other side. So when I do that, so we'll get 7 by 6 into 5 cube plus 1 by 6 into 5 power 4 minus 1 by 6 into 2 power 4. These are the values. Then divide by 7. You'll get what is the value of C1. So can you tell me what is the values of C1? Sorry,
11 by
sorry. I
6.
think yes, I missed that. So it has to be minus 11 by 6 into x7 cube over. Okay, right. So what is the answer? Minus
54.5, sir.
54.5. Okay. So this is my equation. So I got what is the values of C1. You can check it out. So in the problem, they are asking both slope and deflection, which means I have to write both slope equation and deflection equation. So first, let us write what is my slope equation. So slope equation. So the final slope equation. What is my final slope equation? So which is equation number 1. So that is my final slope equation. Let me take this equation. Let me copy this. Put it here. So only thing is C1 is minus 54.5. This I have to change. So minus 54.5. Other things are same. So let me call this as equation number 3. Similarly, let me identify what is my deflection equation. What is my deflection equation? So deflection equation is this one. So equation number 2. So equation number 2 is my deflection equation. Let me copy equation number 2. Put it here. So here, you know that this one C1 and C2, there you don't have value. C1 is minus 54.5. So minus 54.5x. So this is the overall value, right? So I will call this as equation number 4. So now I got these two equations. So this is the overall sketch of the equation. Okay, so now let us go to the question, what they are asking. We will solve one by one. First one, they're asking you to identify what is the slope and deflection at what location? At 5 meter. They're asking slope and deflection at 5 meter. So which means, so what I have to do, I have to substitute, I have to identify what is slope at 5 meter and what is deflection at 5 meter. So first, slope at 5 meter. In equation 3, I should consider the equation up to 5 meter. So substitute 5, positive value here. Substitute here 5 minus 2, 3, positive value. Here 5 minus 5 is 0, so no need to consider this. So my equation is this. What is my slope equation? EI dy by dx is equal to, so 11x square by 2, 11x square by 2 minus 54.5 minus 7 by 2 x minus 2 the whole square minus 2 by 3 x minus 2 the whole cube. This is my equation. In this equation, let us substitute x is equal to 5. Substitute x is equal to 5 meter. I will get EI dy by dx. So is equal to, so 11 by 2 into 5 square minus 54.5 minus 7 by 2. So 5 minus 2 is 3. So 3 square minus 2 by 3. So here also substituting 5. So I'll get 3. So 3 cube. Okay. So find out what is the values of EI dy by dx.
33.5.
So we're getting 33.5. Good. So now, so let me identify what is dy by dx then. So dy by dx is 33.5 divided by 14,000. So because EI, we already know it is given, which is 14,000. So in the question, we apply that. So 14,000. So divided by 14,000. We're getting 2.393 into 10 power minus 3. This is in radians. The slope, it is in radians. Okay. So this is the slope value at x is equal to 5 meter. Now let us identify what is the deflection. So what is deflection at 5 meter? So which means, again, I have to consider the equation accordingly. So x apply 5. So positive 5, positive 5 minus 5, 0. So I have to consider up to this. So which means my equation has to be from here to here. This is my equation. May have this. So let me have it here in the deflection. This is my equation. Okay. So now what I have to do, I am going to substitute the values of 5. So substitute the x is equal to 5. So x is equal to 5. So EIY is equal to 11 by 6. Okay. So 11 by 6. So 5 cube minus 54.5 into 5 minus 7 by 6. So 5 minus 2 is 3. 3 cube minus. So this is, I think, 1 by 6, right? I think I can cancel this. So this is 1, this is 2. So this is 1 by 6. So 1 by 6 into x, sorry, into 3 power 4. So what is EIY?
Minus 88.33.
So EIY is minus 88.33. So now let us identify what is y. So y is minus 88.33 divided by 14,000. So divide this by 14. So what will get? Are getting minus 6.309 into 10 power minus 3. What is the unit? Meter. Okay. So in that case, if I convert it to mm, so your y is minus 6.31 mm. Yes, this is the value that you are getting at x is equal to 5 meter. Okay, so in this problem, if this 6 instead of the 6.3, okay, if it is more than 7, okay, so whether if it is more than 7.1 or something like that, automatically you no need to identify maximum deflection. Okay, directly you can conclude that so your train will fall, and you can give some suggestions regarding to that. Okay, so but now the answer is 6.7, so still we have to check it out. So this is the location, this is what you are getting at this location. For example, if this beam is bending, so it will bend like this. Okay, so it will bend like this. So at x is equal to 5 meter, this location you are identified as 6.5, 6.3. Okay, but still you don't know where you have maximum. Okay, so only at maximum you can check it out, so whether your train will fall or not. So in that case, still the problem is not over. You have to identify what is the maximum deflection. Okay, let us identify what is the maximum deflection. So let me go for maximum deflection. So when your deflection will be maximum for a simply supported
Slope is
beam,
0.
yeah, for simply supported beam, your slope should be 0. When your slope is 0, that location you have maximum deflection. So before we proceed, we have to identify so some location where you have maximum deflection. Okay, so இதான் என்னோட beam. Maximum load எங்க இருக்கு 7 kilonewton. It is acting at B. Okay, the 4 kilometer is a UDL which is acting along this direction. So my question is whether you have maximum deflection after 5 meter. No, you don't have any maximum deflection after 5 meter. Okay, similarly another question, so whether you have maximum deflection before this 2 meter.
No, sir.
No, that is also not possible. So in that case, I can conclude that my maximum deflection will be under the range of 2 meter to 5 meter. Okay, my maximum deflection will be under the range of 2 meter to 5 meter. So why we are concluding this? Because based on that only I can take my beam. What is my equation? Okay, that's why I'm concluding. So it is from 2 meter to 5 meter. Okay, now let me take my slope equation. So where is my slope equation? This is my slope equation, right? So let me take, this is my slope equation. You know that your maximum deflection is under the range of 2 to 5 meter. So which means maximum 5. So in that case, I don't want to consider this last step. So I can cancel this last equation. So 2 to 5 now, I have only up to this equation. Okay. So now I will consider. So let me consider EI dy by dx is equal to 11 by 2 x square minus 54.5 minus 7 by 2 x minus 2 the whole square minus 2 by 3 x minus 2 the whole cube. This is my equation. Here your dy by dx is 0. So let me put dy by dx is 0. So 0 is equal to. So here is the complications. So let me consider. So 11 by 2 x square minus 54.5 minus 7 by 2. Expanding this x square minus 4x plus 2. Sorry, plus 4. Right? A minus b the whole square. Minus 2 by 3. Expand this. So can you tell me what is the formula for this x minus 2 the whole cube? So 2 by 3 x cube minus, so 2 cube. So 2 cube is 8 minus 3a square b, right? So 3 into a square is x square into 2, right? So plus 3 a b square. So x into 2 square, right? Any doubt on this? A minus b the whole cube formula.
No, sir.
Yeah. So which means I will get 0 is equal to 11 x square by 2 minus 54.5 minus 7 by 2 x square minus 4x minus, sorry, plus 4 minus 2 by 3 x cube minus 8 minus 6x square plus 2 2s are 4, 4, 4 3s are 12. So 12x. Okay. So I'll split it up accordingly. So in terms of x cube. Okay. We may split it up accordingly. So what to do? 11. So I will take all the x cube first. Okay. So and then we'll put one by one. So we'll start with x cube. So x cube, if I check, I have x cube only in this portion. So which is minus 2 by 3 x cube. So I'll write as minus 2 by 3 x cube. So this part is over. Sorry, this is over. Next, when we go to x square. So what are the terms which is having x square? Let me add it. So plus this one, 11 by 2. Then here, minus 7 by 2. Then minus into minus, plus, right? Plus 12 by 3. Okay, 6 2s are 12. 12 by 3. Anything else in terms of x square? I think that's it. So x square, this one, this one, this one. This is the terms which is related to x square. So this x square. Okay. Next, let me talk about x minus 4. So 4 into 7 by, so this one we have to multiply, right? So 7 into 4. So 28 by 2. So minus of minus plus. So plus 28 by 2. Okay. Next, this one minus. So minus into plus minus. So minus. So 24 by 3. 24 by 3x. That's it, I think so. So this is my term. Okay. Then remaining. So minus 54.5 minus 7 for 28 by 2. Okay. So minus, how much is this? 24 by 3. Sorry. It is not 24. It is 16 by 3. Minus. So minus or plus. So plus 16 by 3. Any doubt on this? This is equal to 0. Any doubt on this? These
No,
equations?
sir.
No, sir.
Yeah, what we'll get? So we'll get minus 2 by 3 x square x cube plus. So these things. So 11 divided by 2 minus 7 divided by 2 plus 12 divided by 3. So we're getting 6 plus 6x square plus this one. So 28 divided by 2 minus 24 divided by 3. You're getting again that is also 6. So plus 6x minus this one 24 54.5 minus 28 divided by 2 plus 16 divided by 3. So we're getting, sorry, minus 63.16. So kindly check it out. I may make some mistakes in my calculator, so maybe.
Correct,
So
sir.
correct arga. Okay. So now what I can do, I have to identify what is the values of x. Yes.
Yes, sir. Yes, sir.
Yes, sir.
So இதுல வந்து you press mode, then eq1 5. இதுல வந்து பாத்தீங்கன்னா we are solving x cube. Okay. So அப்போ வந்து இதுல வந்து 4. So it is asking what is a. So what is my a value? A value is minus 2 by 3. So minus 2 divided by 3. Next, it is asking b value. My b value is 6. So plus 6. 6. Next, it is asking c value. So c value is in terms of x. That is also 6. So 6. And d value. D value is without any x, which is minus 63.166. Substitute it. So you'll get three values. X1, which is minus 3. X2 is 8.7. X3 is 3.38. Okay, these are the three values. So one value what we are getting is minus 3. This minus 3 is not applicable because your beam is not a negative beam. Okay, so this is, you can neglect this. Next value is 8.7. So this also, if I consider, the total length of the beam is only 7 meter. Okay, total length நம்ம beam ஓட length வந்து 7 meter தான். இப்போ 8.7 it is also not applicable. Okay, so this is also you should not consider. Third one is x is 3.38. So this is a correct value. So this is in between 2 to 3, 2 to 5. Okay, maximum deflection எங்க கண்டுபிடிச்சோம் நம்ம already we identified. We had a suggestion that the maximum deflection will be from 2 to 3, 5 meter. So 2 to 5 meter length. Okay, so it is in between, which is 3.383. Okay, so this is the correct location. So where you have maximum displacement. Okay, so this is what I am going to consider. So solving here, so what you'll get, my right x value is 3.383 meter. So this is the location where I have maximum deflection. Okay, now let me take what is the maximum deflection equation. So equation number 4. So let me take what is my equation. So this is my equation. So in this equation, I'm going to identify. So I have to substitute x is equal to 3.38. So let us reduce the equation accordingly. So according to Macaulay's rule. So 3.38 x positive value. You can consider this. 3.38 minus 2, again 1.38 around. That is also positive value. You can consider this also. 3.38 minus 5. So this is negative term. So which means this you should not consider. So this you can cancel this. Okay. So what is my equation? My equation is EIY is equal to 11 by 6 x cube minus 54.5 x minus 7 by 6 x minus 2 the whole cube minus 1 by 6. Okay, so which we cancelled here already. So 1 by 6, I think x minus x power 4. Okay, so we missed that. So into 1 minus x minus 2 the whole power 4. Okay, this is my value. Right? So now let me substitute x is equal to 3.38 in this. So what will get? You'll get EIY is equal to 11 by 6 3.383 the whole cube minus 54.5 into 3.383 minus 7 by 6 into, so 3.383 minus 2. So what will get? You'll get 1.383 whole cube minus 1 by 6, again 1.383 whole power 4. Just substitute it, find out what is EIY. So we're getting minus 117.089. Okay, so now let us identify what is y. So y is minus 117.089 divided by EI. EI is 14,000. So divided by 14,000. So we're getting minus 8.363 into 10 power minus 3 meter, which means my y is minus 8.36 mm. Okay, this is the maximum deflection. Okay, this is y max. Now, according to the question, they mentioned that if your y is more than 7 mm, your tail will fall. So, which means according to this, your tail will fall because it is 8. Okay, so 7 விட அதிகமா இருக்கு 8. So, how will you conclude? So I am concluding that it will fall, but I have to give some suggestion. Okay, so என்ன suggestion கொடுக்கலாம்? So you know that this y is related with what? இந்த y வந்து எப்படி வந்துச்சு? So ஒரு value. So this value. Okay, value divided by EI. This is what we are getting. So E is the Young's modulus, which is material related. Okay, it is material related. So which means I can't able to identify what will be the values with respect to that. Okay, so material வந்து என்னால change பண்ண முடியாது. So your material is always constant. Okay, so it is constant. Leave it. So but I can change. I is the cross section. So it depends on how much the cross section is. Okay, so how much the cross section is. Okay, how to suggest this? Okay, so you know what is the value. So what is my y? Y has to be, what is my limit of my y? My y limit is minus 7 mm. Okay, so minus 7 mm. So my y is minus 7. Okay, this is equal to, you know that when I increase my value of I, what happens? Your deflection will decrease or increase? Your deflection will decrease. Okay, so upon the what I give one suggestion. So suggestion is increase your inertia I. Increase your inertia I. Okay, so if I increase my inertia, I will get my better results. But how much I have to increase? That you have to consider, right? So for that, so I am going to identify what is the value. Okay, minus 7 is value divided by EI. Okay, right? So what I am tending to do is, I am going to identify what will be my EI value with respect to this. So we know that, so my value here, what we got is minus 117.089. Let me substitute it here. So what I'll get, minus 7. This is the max limit. This should be minus 117.089 divided by EI. Which means, what is my EI value has to be? Okay, this one I have to substitute into 10 power minus 3. Okay, because I am substituting in meter. Okay, so what will be my EI value? So EI value will be minus 117.089 divided by minus 7 into 10 power minus 3. Okay, what is the EI value I am getting?
16727.
So you're getting around 16727. Okay, so my original EI value, what I got is 14,000. Okay, so when I subtract this, what I'll get? I'll get, so I have to increase around 2727 kilonewton meter square. I have to increase additional value so that I can achieve this deflection less than 7 mm. So this is the additional EI value, which has to be included. How to do that? I can increase the breadth. Okay, we know that I is BD cube by 12. Okay, uh, if I consider this D, if I increase the D value, automatically even 1 mm if you increase, it is 3 times. Okay, so 3 times it is increased. Automatically, it will increase your moment of inertia, which automatically decreases the maximum deflection. Okay, this is how we can able to solve this problem.